Hello and welcome to lesson 1 of week 16. In this lesson, we're going to look at errors and exceptions in Python. My name is Mildred. In Python, we have syntax errors and we have exceptions. And during parsing, syntax error occur, and these errors are errors that occur when we violate a rule on how the code should be written. For instance, let's try to generate a syntax error. Let's say x is equal to 10, and then we say if x is equal to 10, we want to print x is 10, else we'll print x is not 10. So we want to generate this syntax error by omitting the colon that is supposed to be here. And when I save this and I run, we're going to have syntax error expected colon. Now take note of how the error is displayed. We always have a caret sign under the problematic line, and it tells us the line. So the first thing it tells us the line where the error occurred, the syntax error, and what was expected or what was missing or what it is supposed to be. So when we read our error messages, we have an idea of what line violates the rule, what are we supposed to do there, and here we just have to put a colon to remove the error. There are several other type of errors like name errors, value errors, and things like that. Let's try to generate things like indentation error. If I put something like print x like this, save, I'll clear and run, we'll have something like syntax error expected colon. Syntax error comes before the indentation error, so I'll correct the syntax error so that we can see the indentation error, and then we'll have indentation error expected block after if. So this is how errors are displayed in Python. We also have exceptions, which are error that occurs during execution. So the code can be syntactically correct, but then they might result in error. So let's see an example of how we can generate an exception in Python. Let's say we have a list of students like this, and the students we have are Mary, let's say Mary, Bob, and John. So I'll put this in quotes, and let's say we use the delete statement to delete the list, and then we come to the next line and try to print that list out. We should have an error because this is syntactically correct, but during execution it deletes the student, and then we ask it to print what was deleted, and then that is not possible. And so when I run, I'm going to have name error, name student is not defined. So this is an example of an exception that occurs during execution. So it's still the same syntax. It tells us the problematic line, and then it gives us the detail of that error. It gives us the name of the error, which is name error. So how do we handle these errors and exceptions in Python? In Python, we have something we call the try except block, and optionally a finally block. It is written like this. So I'm going to delete this and I'll put a try statement. You write try, a colon, and then within the try block we're going to put in all of the code we want to test for errors. So every code we write that might result in an error is going to be in the try block. So say student equal to, let's just use this, and then we say delete student, and then we say print student. So we know that this is going to result in an exception. And then we'll have the except block, and then in the except block we'll say print error, student is not defined. But because we know in advance what kind of error this will generate, we put student is not defined. We can just put something like error, and error occurred during execution. So this is the basic way that you will not actually use professionally, but this is how we do the try except block. So now it is not going to fail with the kind of error messages we have, but it's going to fail with the error message we ask it to print. And so we don't have those cryptic error messages, and this is how you want to handle your error in production, where you don't want to terminate codes because of something. We can also put like an else here to say else, and when we have else, we execute something if no errors were raised. And so let's say else print no error occurred, and if we want to print something or do something after everything, and we say regardless of what happens in the try except block, print something. Let's say finally block executed. And when I clear, we'll always have this printed out, the finally block, no matter what happens in the try block. And so when I run, I will have an error occur during execution, finally block executed, things like that. So this is the syntax. We can have several except blocks. Let's give an example. Let's say I want to catch a specific error. We don't want to have like just a general error. Let's say we know in advance that a name error might occur. We want to catch name error like this. And we'll say name error, and what we want to do now is to print student is not defined. When I save this and I clear, we're going to have that variable student is not defined because we caught the name error. What if we use value error? Then this error is not going to be caught because it is a name error and not a value error. And when I save and I run, I'm going to go back to the basics of like an unhandled exception when I had no except block. So I'm going to have the cryptic error message printed out because I'm catching just the value error, not the name error. We can say we want to catch several types of error. Let's say name error, value error. We want to catch things like runtime error. There are many errors like that. And we want to give it a name. And then we say has, an alias has E. So we want to use this E in our print statement. And we want to say print error. And then maybe we want to say error. And we want to print the exact error message, error E, like this. And then when I clear here and I run, I'm going to have that printed error E. Now why is it printing error E out like this? Because I put it has. So let's say print error and then a comma E. So this is supposed to be the correct way of writing it. So clear and run, and I have error name student is not defined. So there are several ways you can print out your error, or you can return something, or something that is understandable, especially in production. If we have all of this, you can have another except block that will catch errors that are not mentioned, like any other error that occurs that is not a name error, a value error, or a runtime error. Let's say you want to print something like unknown error. So let's say I'm not catching name error. So this time I wanted to just print out unknown error instead of filling back with a cryptic error message. So when I say run, it will say unknown error. So you get the idea of how we do things like this. So you use the try block, put all your block of code that might result in an exception in the try block. And the except block, several except blocks, you can actually handle selected exception like the name error as we just did, or like a value error, or several group of types of error. And then another except block that handles any error that is not caught, so that you don't end up in an unhandled exception. We can actually raise an exception using the raise keyword. Let's say for instance we have x is equal to, let's say input, and we want to say enter a number. We want this to be a number, and we want to say if x is not equal to, or let's say if type of x is not an int, we want it to raise type error, only integers are allowed, like this. So you can use the raise like this to raise an exception in Python. And so when you say enter a number, and I put, instead of a number, I enter a name, big, and it's now said type error, only integers are allowed. So you can raise errors like this in Python. We have built-in exceptions in Python, and I'm not going to go into detail about the built-in exceptions because it's going to be part of your assignment. We have exceptions like arithmetic error, where it's an error that is raised when an error occurs in numeric calculations. We have things like floating point error, when a floating point calculation fails. We have things like index error, when it's raised when an index of a sequence does not exist. A lot of inbuilt Python errors that you will see. We have error like keyboard interrupt. I'm just naming errors that you see most frequently. Keyboard interrupt, where it's raised when you press Ctrl C or you press Ctrl Z or delete during a process. So these are the kind of inbuilt Python exceptions that you will encounter, and I want you to read more about them. When they are raised, understand them, and you'll be able to debug your code, and you're able to read error messages, and you're going to understand them. So this is where we end this lesson. In the next lesson, we're going to look at how to handle files in Python. Thank you, and see you in the next lesson.